In this session, we'll understand the basic terms used in statistics, that is mean, mode, median, and the range. As far as basic statistics are concerned, in general, if you see, statistics is generally categorized as a descriptive statistics or inferential statistics. Now, descriptive statistics consisting of these basic terminologies, the values that we're interested in, and always to analyze for the data that we have. Could be mean, median, mode, and range. Now, first let us focus on mean. Mean is the average of the set of data. To calculate the mean, first we need to find the sum of the data and divide by number of data. The number of data. Now let us consider this is the data set that we have and want to find out the mean. First we need to get the sum, divide the number of the data that is available, and we'll get the mean of this 1, 2, 3, 4, 5, 6, 7 number of 6 number of data sets. We'll get the mean as 11.5. Now let us take an example. Now in electronic store sells an item at following rates, and what could be the mean price for this? It's nothing but taking the sum. That sum comes out to be 22.25. It's divided by 7 number of such kind of prices, which gives you the mean of 317.86 rupees. This is your mean. Then next is what is median. It's actually the middle number, the set of data when the data is arranged in a numerical order. Now, so first what we need to do is you need to set the arrange the data in particular form, that is from smaller number to higher number, and then focus on the first middle two values here, and then take the average of these two. Again, we will lead to a one value called also calculated as 11.5. So median here is 11.5. Yes. Now let's take an example. The same example for calculating the median. So the values are again arranged in. Now here we are directly saying that the median is 325 because it is exactly located at the center. There are total 7 number of price values. The middle number we are directly selecting as 325. In earlier case, there were 2 values because the number of data sets are 6, that is even number. Now what is mode? Mode is the frequency, number of times it occurs. So here in this case, the data set that we are considering the same, the number 11 is occurring more than 1, so the mode is 11. Actually it is occurring 2 times, so we have considered that as binary. It is occurring 2 times, so it is a single mode. Now take an example here. This is the data set that we have. Now if you look at 5 and 7 are coming for are appearing for twice, so you can say it here it's a bimodal. So there are 2 modes available, number 5 and number 7. So it's referred as bimodal. Now let us now focus on this example. Can we see any repetition? No. So there is no mode available here. Now again take that example. What is the mode here? There is no mode actually. Thing is repeating again. So you can remember that mode means the number of times that occurs most. So the mode and most are alike. So we can remember like this. Now let us focus on the concept of range. Actually, range is what? It's a difference between the largest and smallest number in a given set of values. Now this is the data set available with us. Now let us calculate range here. What we need to identify? We need to identify what is the smallest number here. This is 26 is the smallest number and the largest number is 50. So the difference between is nothing but the range. So the range of the values been spread over is starting from 26 to 25 to 55. Oh, yeah, and it is the range is 29. So what we understood here is mean is the average, median is the number of average of the numbers in the middle, and the number that occurs most is mode. Actually, this is applicable in different situations. There's what large variety of applications, but mean and mode and the range, these values are used for uh, quality control process. It is actually used to plot different graphs, which we refer as a tools. So these are 7 basic QC tools. The tick mark symbols showing that those quality control tools which uses these basic concepts of statistics. For example, check sheet, histograms, Pareto, charts, control charts, and scatter diagram. I'm considering an example here of this control chart where we have got data, and that data is again further processed to calculate the mean. And there are such kind of a 27 number of sample means been calculated. For every mean, a sample mean is representing a set of data. So likewise, there are so many sample means available. Now again, we want to take the average of it. So mean of mean, that will be considering average of average in maybe simple term. So that's so what we need to do, we need to add all these values and get the divided by 27. We'll be getting this value here. And again, the same data set is used to calculate the range. So that range value pertaining to the set of values for which the mean is 28.2, and again the range for that set of value is 14.6. So likewise, again 27 number of range values that we have calculated here, and the average of this range is this. So with the help of which again we'll be calculating some upper and lower control limits. Again, upper and lower control limit be used to calculate the mean, and this data, if we plot it here graphically, we could get something in our hand to analyze, which is very much easier as compared to looking at simple data here. So here what we can see, up to this the process is at center, and then there is deviation either towards, in this case, towards lower control limit, and abruptly it is moved to the upper control limit. Again it is moving up and down. So the process is deviating from center, and that we can analyze. So for this analysis, what we have to do, we have to plot the graph. For plotting of graph, we need the data. So data is related to calculation of a sample mean and the range, and how to calculate that sample mean and range, that we have studied. So what we are seeing in this particular slide is application of the concept of calculation of a simple mean and average. Similarly, the second example that we could see here is again the upper control limit that has been calculated here is 35.87. The lower control limit is 23.59, and the average of this is the x bar is nothing but mean here. So with respect to the specification limits, how the process is deviating, that we can understand from this. Again, the statistics can also be used further for analyzing the deviation with respect to the specified limits. So again, this particular way in which the data can be plotted for its further analysis. So here, this data plotted in the form of a graph. This graph is called a histogram, which is one of the quality control tool that we have seen in the list. So this is what I would like to discuss here for this session, the applications of the basic terms that we use. Now here, these are some of the references from which I prepared this. So you can read this further for further understanding.